So next we have the Mayan system. The Mayan system is a bit more complicated. They have a base 20 position that then becomes a base 18 times 20 positional system, and I'll talk more about that in a minute. Their symbols are for ones and fives, and then they also have a symbol for zero. Their symbol for zero is probably their most complicated symbol. For one, it's just a dot. So here you have 1, 2, 3, 4. It's literally 1, 2, 3, and 4 dots. Once you get to 5, you've got this horizontal line. And then 6, 7, 8, and 9. Once you get to 10, 2 horizontal lines. So the numbers 1 through 19, I was going to say 1 through 20, but 1 through 19 are pretty straightforward. A dot for 1, that line to represent our fives. Their place values, this is where things get a little different for us. First of all, their place values go vertically instead of horizontally, which is what we're used to. Their place values are going to go vertically, number 1. And number 2, they're based on a 20 and then 18 times 20. So you have your ones place, life is grand. Then you have your 20s place, and the next one, here's that 360. You saw the 3600 with the 60 with the Babylonian system. Here we have 18 times 20, which is 360s place. Then 18 times 20 squared, 7,200. Then 18 times 20 to the third power, which is 144,000, and it would keep going. You'd have 18 times 20 to the fourth, 18 times 20 to the fifth. So it's just a little different than what we are used to, and that might be putting it mildly. But let me show you how this works. We're going to look at an example here, and it's going to be 27,408. We're going to put this in Mayan notation, and I will scroll down in just a moment here, but I wanted to point something out. We are going to go up to 4 place values here. The 27,408. Obviously, we're not reaching the 144,000, but we are going to get into the 7,200s. So we're going to be into 4 place values. So I'm going to use the calculator again for this one. So 27,408. So how many 7,200s are in this number? So again, I'm going to pull up the calculator. So 27,408 divided by 7,200 is 3, and then we have a long decimal, but it's that 3 that's important to me. So we have 3 7,200s. So let me scroll back up here for you all. So then we're going to look for 360s out of what's left. Okay. So 27,000, actually let me do this. 3 times 7,200, I have a real simple calculator here, so I don't want to overextend what it can do, is 21,600. And if I subtract that from 27,408, I have 5,808 left over. So I need to see how many 360s, because that's my next lower place value, how many 360s go into that? Well, it's 16 and some change. Okay, I'll go back to my calculator now. So I have 16 360s. It's 5,760. And I'm going to subtract that from 5,808, what I started with. And that leaves 48. Things are much simpler now. If you look back up here, the next lower place value is the 20s place. This one you can do in your head. And from 48, there's 2 20s. And then there's going to be 8 ones. So now we are going to represent this in Mayan notation. So this is going to build vertically. So I'm going to start on the bottom with my ones place. There's 8 of them. So it's 5, 6, 7, 8. Then the 20s place, there's 2. So I'm going to leave some space and then do a 2. Then we have 16 360s. So there's 5, 10, 15, and 16. And then 3 of the next place value, 3 7,200s place. So there you have 27,408 in Mayan notation. And like I said, it makes you appreciate all the more our system. We use the Indo-Arabic or Hindu-Arabic system. And I have a table here that goes through a little bit of the history of where some of our numerals came from, just 0 through 9. And then obviously we have a base 10 system. So when you're teaching, I would be very, very doubtful if you're going to be teaching anybody the Mayan or the Babylonian system. You might touch on the Roman numeral system or even the Egyptian system, just that idea of counting. If you wanted to do something fun, students might think it's fun to write in hieroglyphics. But we focus on our base 10 system using the numerals, again, 0 through 9. And I've got the rest of these notes here. I just have some pictures about different manipulatives that might be used. One is an abacus, a place value abacus. So ones place, tens place, hundreds place, thousands place, 10,000s place. Or you could have units, strips, and mats. You could cut these out of graph paper. You could print them on cardstock. You could print them out on paper and then glue them to cardboard. But you have your units, your ones, a strip, which would be 10, and the mat, which would be your 100s. Then there's the idea of using sticks in bundles to represent tens, where you bundle together 10 sticks. You could use 10 straws for that even. Or even the Unifix cubes that we talked about before. You could snap together 10 of them, 10 ones to represent tens. In some ways, I feel like maybe the most famous are the base 10 blocks. So this is just the 3-dimensional version of the unit, strips, and mats. So here we have the cube for 1, the long for 10, the flat for 100, and then you have the block for 1,000. So when you're introducing our base 10 system, any of these manipulatives will work to give students something tactile that they can touch to really grasp our different place values. Because like I said, we get so used to it, we understand our place value system so well as adults that sometimes we lose sight of the fact that this can be complicated. As strange as maybe the Mayan or the Babylonian seems to us now, that's how our base 10 system can seem to some of our kids. And so you want to be well aware, well versed in these different manipulatives.